One for solving equations in one variable. When we're solving equations in one variable, we want to make sure we get the variables on one side of our equation so that way we are solving for it. If we look at example 1, we have 5 times 2x minus 9 is equal to 7x minus 60. We want to distribute first before we do anything else. So when we distribute, that 5 times 2x is 10x, and the 5 times negative 9 is negative 45. So we're going to have 10x minus 45 is equal to 7x minus 60. From here, we want to get all of the x's to the same side. So I'm going to bring the 7x over to the 10x, so that way my x stays positive. And I'm going to use opposite operations, or inverse operations, in order to move my terms over. So the 7x I'm going to subtract from each side. It's going to cancel out from the right side. Bringing it over to the left side, I have 10x minus 7x, which is 3x. Then I drop everything else down. So I'm going to have 3x minus 45 is equal to negative 60. From here, I'm going to move the 45 over to the other side by doing addition. So I'm going to add it to both sides. And then we have the 3x that we dropped down is equal to negative 60 plus 45. That's going to give us a negative 15. And then we're going to divide each side by 3 to get x by itself. And x is equal to negative 5. Now you can always check your answer whenever you get these by plugging that answer into your original equation and solving. If you get a true statement on both sides of your equation, then you know your answer is correct. If we look at example 2a, we have 3 times 2x minus 3 is equal to 6 times x plus 1 minus 10. So we're going to distribute the 3 on the left side, and we're going to distribute the 6 on the right side. So 3 times 2x is 6x, 3 times negative 3 is negative 9, is equal to 6 times x is 6x, and 6 times 1 is 6. Drop down the minus 10. Combine like terms on each side if you can. The 6x minus 9, you cannot combine anything. They're not like terms. The 6x plus 6 minus 10, you can combine the 6 and the negative 10. This is going to leave us with 6x minus 9 is equal to 6x minus 4. If we move the 6x over from either side, we're going to subtract it from both sides. They cancel out on each side. We drop down the negative 9 and the negative 4. Now we ask ourselves, is negative 9 equal to negative 4? No, that's not a true statement, so we have no solution. If we look at example B, we have 3 times 2x minus 3 is equal to 6 times x plus 1 minus 15. So on the left side, we're going to distribute that 3. The 3 times the 2x is 6x. The 3 times negative 3 is negative 9 is equal to, drop that down. Then on the right side, distribute that 6. 6 times x is 6x. 6 times 1 is positive 6. From here, combine like terms on the right side. The 6 minus 15 is negative 9. So we have 6x minus 9 is equal to 6x minus 9. You can see that both sides here are the same exact thing. So this is going to give us a true statement. If you didn't see that from there, you can actually subtract the 6x over from each side. Realize that they cancel out and get negative 9 is equal to negative 9. So this is a true statement. So our answer is all real numbers. If we look at example C, we now have fractions. So something that was brought up in one of the classes is are you able to get rid of those fractions by multiplying the entire equation by your least common denominator? In this case, yes, you can do that. So if we look at our denominators here, we have 3, 2, 4, and 3. The least common denominator between all of these fractions is 12. So we're going to multiply the entire equation by 12. If you look at this, the 12 divided by 3 is 4. So we're going to multiply 4 by the 3x plus 4. The 12 divided by 2 is 6. So we're going to multiply the 6 times the 1x. Drop down the equal sign. 12 divided by 4 is 3. So the 3 is going to be multiplied by the 1x. And then the 12 divided by 3 is 4. So the 4 is going to be multiplied by the negative 7. From here, multiply out or distribute. The 4 times 3x is 12x. The 4 times 4 is 16. 6 times 1x is 6x. Drop down the equal sign. 3 times x is 3x. And 4 times negative 7 is negative 28. From here, if you can combine like terms, combine them. The 12x plus 6x, you can combine to get 18x plus 16 is equal to 3x minus 28. So from here, move the 3x over. The 3x is smaller. You want to have the x be positive if you can. So we're going to subtract the 3x from each side. And we're going to get 15x plus 16 is equal to negative 28. We're going to move that 16 over by subtracting it from each side. Now we have the same signs. Same signs, keep the sign, add the numbers. Drop down the 15x is equal to, we're going to keep it negative. The 8 plus 6 is 14. The 2 plus 1 is 4. So now we have 15x is equal to negative 44. Divide by 15. We get that x is equal to negative 44 over 15. You can't simplify that any further, so you can leave it just the way you see it. So from here, if we look at example D, we have 3 times 2x minus 4 is equal to 7 minus x plus 5. So we're going to distribute that 3 on the left side to get 6x minus 12. That negative on the right side will distribute, so we're going to change the sign on each of the terms on the inside of the parentheses. We'll get 7 minus x minus 5. Combine like terms. The 7 minus 5 gives us 2. So this is going to be 6x minus 12 is equal to 2 minus x. I want to move that negative x over to my 6x, so that way my x stays positive. I'm going to get 7x minus 12 is equal to 2. Now I want to move that 12 over by adding it to both sides. I get 7x is equal to 14. And now I'm going to divide each side by 7 and get x is equal to 2. Sometimes you're going to be asked to solve for a specific variable as well. If we look at example 3, we're solving for a specific variable. So sometimes when I do these, I like to circle the variable that I'm working with and move everything else over to the opposite side of our equal sign. In example A, we have A is equal to 1/2 times B times H. We're looking to get H by itself. So I circle my H. I want to get everything else over to the other side. If my H wants to stay where it's at, I have to get rid of that fraction first. Remember, when you're dividing by fractions, it's the same thing as multiplying by the reciprocal. So the reciprocal of 1/2 is 2. We're going to multiply each side by 2 to get rid of that 1/2. So this 2 and this 1/2 cancel. We're going to be left with 2a is equal to b times h. Again, we want to get that h by itself, so we're going to divide each side by b. Those cancel out, and we get that h is equal to 2a over b. If we look at example B, we have k is equal to 1/2 m times v squared. We're getting m by itself. So again, m by itself. I want to take that 1/2 and I want to put it over to the other side. I'm going to multiply each side by the reciprocal, which is 2. That'll get rid of that 1/2 and the 2 on the right side, and this will leave me with 2k is equal to m times v squared. Again, I want to get that m by itself, so it's being multiplied by that v squared right now, so I'm going to divide each side by v squared. Those cancel out on the right side, and I'm going to be left with m is equal to 2k over v squared. For C, I have I is equal to P times R times T. We want to get T by itself. So we're starting with I is equal to P times R times T. I want to get P and R over to the other side. Right now it's being multiplied by this T, so I'm going to divide each side by P, R. These would cancel out on the right side, and I'd be left with T is equal to I over P times R. If you want to put the lines on the I and make it look like an I, you can do that too. It's fine. If we look at D, we have A is equal to P times 1 plus R times T, and we're getting R by itself. Okay, so we want to undo that distribution first. We can divide each side by the P, or we can distribute the P. It's totally up to you. If we were to distribute the P, we'll do this one of two ways. We would have A is equal to P plus P times R times T. The P would have to be subtracted, and we'd be left with P times R times T is equal to A minus P. We want to get R by itself, so we would divide each side by what's not R, which is PT, and get that R is equal to A minus P over P times T. This could be your answer, or you can separate it and cancel out where you can. You can also start from the A is equal to P times 1 plus R times T and divide each side by P first. If you were to do that, you'd be left with A over P is equal to 1 plus R times T. Subtract the 1 from each side. You'd be left with A over P minus 1 is equal to R times T. From here, you're getting the R by itself, so you're dividing each side by T. When you're dividing all by T, you have to think about this. You have A divided by P minus 1 all over T. You can't leave it like that. So you have to make sure that you keep working. When you do this, think about it as, A over P minus 1 divided by T is equal to R. So from here, keep working. That 1's going to have to turn into something over something to add it with that P as your denominator. So it's going to be A over P minus P over P divided by T is equal to R. So remember, these are practically in parentheses. So we're going to have A minus P over P divided by T is equal to R. From here, change, flip. So A minus P over P times 1 over T is equal to R. So again, you're going to have A minus P over PT is equal to R. So same answer, just two different ways of doing it. One's a lot longer than the other one, obviously. So it's totally up to you which way you want to do it. I would distribute first and then go, just because this specific problem is the way that it is.